So test cell layout, and this isn't going to be anything overly complicated, but we have our device under test power supply, we have our current measurement, we have our test inverter, we have our three-phase current measurements, our device under test, our motor, our torque sensor, our load machine, and our power supply. And in an ideal setting, we want all of these cabling routes to be pretty separate. We want to avoid parallel paths, we want to avoid loops of cable, we want to make everything as short as possible. So in your ideal layout, you actually have these things almost on opposite sides of the room. You want to increase that distance. You want your measurement cables to never be crossing your current carriers, because we want to avoid those cross sections. And if we have to have them crossing or close to each other, we want to avoid parallel paths. We want to have things crossing at 90 degrees. And that's kind of like some old school circuit layout stuff. If you have to have something close, make it close for a short distance and bring that back to your measurement unit. Have those be as short as possible. Same goes for the torque and speed cables. Have those not running in parallel with anything. You have CAN bus temperatures, avoid parallel paths, because those are going to pick up noise and could result in grounding issues. So avoid loops, make your cables as short as possible, avoid parallel paths. Create Faraday cages. We'll touch on this a little bit later, and we have some YouTube videos on details of this, but basically complete your shielding path. And really look at your grounding, especially if you're having a lot of issues creeping up. If you have instrument grounds, use them. Make sure you have a really good grounding path. Use your braided cables for shielding. Use really low resistance shields, a grounding shield. So there's some stuff you can do just in layout. And if you roll in the instrument rack in, just have this stuff in mind.